Hello my dear students, I warmly welcome you to CR Digital Classes. So in this lecture, we are going to discuss about the second method, that is Newton Raphson method. Okay. So in this Newton Raphson method, we are going to find a real root of a system of non-linear equations. See the problem first of all. Solve the system of equations by Newton Raphson method. That is, what is the system of equations? 3y(x square minus 10x plus 7 is equal to 0. Y square minus 5y plus 4 is equal to 0. Same system of equation we already derived that by using the iteration method. Okay. So now why we are discussing the same system of equation means, so if you get the clarity, okay, so definitely you will get the clarity after discussing this system of equations. Okay. So first of all, see the solution. Given system of equation are, so you can take system of equations as equation number 1. Okay, so therefore f of x comma y is equal to 3y(x square minus 10x plus 7 equal to 0, and g of x comma y is equal to y square minus 5y plus 4 is equal to 0. Okay, so let x naught comma y naught be an initial approximation to the root of system of equation number 1. Okay, by observing clearly you can say that x comma y is equal to 1 comma 1 is the actual root of that equation number 1, but what we are considering approximation root as x naught comma y naught as the initial approximation for the given system of equations number 1. Now in this Newton Raphson method, okay, if x naught plus h comma y naught plus k is the root of the given system, okay, so we are taking that x naught comma y naught, okay, x naught comma y naught as the initial root. He is saying that x naught plus h comma y naught plus h is the original root. Okay, x naught plus h comma y naught plus h as the root of the given equation. Then it must have f of x naught plus h comma y naught plus k is equal to 0. Similarly, g of x naught plus h comma y naught plus k is equal to 0. That is, so అంతే కదా. సో మనకి x naught comma y naught అనేది మనం ఈ సిస్టమ్ కి రూట్ అని తీసుకుంటున్నాం అంటే ఆ పేర్ అయితే ఏదైతే ఉందో ఆ ఎలిమెంట్, okay, so that has to satisfy the given system of equations. Okay, so therefore that is taken as equation number 4. Okay, so now this entire method we are going to find out this small h and k values, small h and k values. Now partially differentiating system of equation 1 with respect to x and y, likewise in iteration method likewise only. So therefore dou f by dou x is equal to 6xy minus 10 and dou f by dou y is equal to 3x square. Dou g by dou x is equal to 0 and dou g by dou y is equal to 2y minus 5. So we did the partial derivative for the equation number 1. Okay, so now we expand both equations. Okay, we expand both equations in equation number 2, this equation and this equation, by using the Taylor series. Okay, so to get the solution of the given system of equation by Newton Raphson method, so given equation number 2, okay, so we have to expand with respect to Taylor series. You know very well Taylor series expansion. So therefore f naught plus h into dou f by dou x naught plus k into dou f by dou y naught. Actually, what is the original Taylor series? You can see here. So original Taylor series, you know very well, whenever you write f of x naught plus h is equal to, the first word is f of x naught plus second word is h by 1 factorial f dash of x naught, okay, plus third word is h square by 2 factorial f double dash of x naught plus up to so on in this format. Okay, whenever you take x naught plus h, then the variable in right hand side also x naught, okay, and h is the interval. So same concept here, f of x naught means you can take f naught plus h by f dash of x means dou f by dou x naught, okay, dou f by dou x naught plus similarly h square by 2 dou square f by dou x naught square. In this format you can write the Taylor series expansion. Same expansion, this expansion only directly I am writing there, where we have x naught plus h, y naught plus k. So therefore, then you can observe carefully. So therefore, f naught, okay, f naught plus h into dou f by dou x naught plus k into dou f by dou y naught, okay. So plus next h square by 2 factorial, h square by next term you will get h square by 2 factorial dou square f by dou x naught plus h square by 2 factorial dou square g by dou square f by dou y naught. In this format you will get, okay. Next second term, but here we required up to first degree only. So therefore, next second equation, g naught plus h into dou g by dou x naught plus k into dou g by dou y naught. So that is equal to 0, taken as this total system of equation taken as equation number 3. We expanded that LHS of the equation number 2, f of x naught plus h comma y naught plus k, and g of x naught plus h comma y naught plus k we expanded with respect to with the help of Taylor series. Now you can clearly here f naught is nothing but f of x naught comma y naught, okay. And you know very well x naught y naught we can consider the initial approximation like 0.5 0.5. So therefore, similarly here g naught is nothing but g of x naught comma y naught, and dou f by dou x naught. Dou f by dou x naught means the partial derivative of the given function f with respect to x at initial approximation x is equal to x naught, okay. The partial derivative of the function f with respect to x at initial approximation x is equal to x naught. So therefore, directly we can write those values. Similarly, this value also you can say, this value and this value also you can say. So now you can see here. Now, by neglecting the second and higher order derivative terms, second means after dou f by dou y naught you will get dou square f by dou f naught, okay. So therefore, by neglecting the second order, why? Because the given equations are second degree and second degree equations only, okay. If you do the derivative for the second degree equation, at the second derivative only you will get the constant. At the third derivative you will get 0, okay. So that's why we can neglect or we can ignore the higher order derivatives greater than 2. So therefore, neglecting the second and higher order derivatives terms in equation number 3, then you will get that only, you will get this term only, f of x naught, okay. So equal to 0, here you will get equal to 0, only up to here you will get the equation. F naught plus h into dou f by dou x naught plus k into dou f by dou y naught is equal to 0, and this second one will become g naught plus h into dou g by dou x naught plus k into dou g by dou y naught is equal to 0 if you neglect the higher order derivatives. Next, send this f naught to RHS, then directly you will get this format, h into dou f by dou x naught plus k into dou f by dou g naught is equal to minus f naught. Next, send this g naught to RHS. So therefore, h into dou g by dou x naught plus k into dou g by dou y naught is equal to minus g naught. If you write the step by step, the length of the problem will increase. So that's why I am writing direct steps. So just kindly understand. To 0. So therefore, after getting that equation number 4 is nothing but that is also in the format of the system of equations, and this equation both together, so we can say that equation system of 4, okay. So now equation 4 has a unique solution, because equation 4 is in the format of the matrix equation. What is a matrix equation? Ax is equal to capital B, capital A into x is equal to capital B, where what is the capital A? Capital A is the coefficient matrix. That coefficient matrix exists in the square, either it is 2 by 2, 3 by 3 or 4 by 4 up to so on n by n order, okay. Then those types of matrix are called square matrix, either 2 by 2, 3 by 3, 4 by 4 up to so on n by n. So capital A is definitely coefficient matrix. Which coefficients? Variable coefficients of the given system of equations. Okay. So therefore, and capital X is the it is a column matrix with variable. Okay. So for example, if you take two variables x and y, that is a column matrix. And capital B is also constant matrix. Okay. It is also column matrix. Okay. So therefore, constant, if you take any constant, for here we have minus f naught minus g naught. After after equal, whatever you have, those comes under the constant matrix. So therefore, system of equation 4 is in the matrix format, Ax is equal to B. Then we have to find out the solution of that system of equation by using the Cramer's rule. You know very well, the Cramer's rule is very useful while solving the problems in system of equations. Okay, by using the matrices. Now clearly you can see the Cramer's rule, how you can use Cramer's rule. For example, if you have a1x plus a2y is equal to c1 and a2x plus a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2 is a system of equations. Now we have to find out the x and y values. Okay, to find out the x and y values by using the Cramer's rule. Okay, so by using the Cramer's rule, how you can do that process? First of all, the given equation in the format of Ax is equal to B. If it is not in the format, we have to convert that equation in format of Ax equal to B. After getting, so you can separate that capital A. What is the capital A? Coefficients of the variables A1, B1, A2, B2. And what is the capital X? It is a column matrix with variables. What are the variables? X and Y. And what is the capital B? Capital B is the constant matrix which are exist equal to an RHS of the system of the equation. In RHS we have C1 and C2. So that is the capital B. Capital B is also column matrix. Now to find the x and values, we have to take the det of the capital A. If det of capital A is not is equal to 0, if determinant of the coefficient matrix is not is equal to 0, then this system of equation has a unique solution. So then x is, you can find x as det of A with respect to x and original det of capital A. And if you want to find the small y value, okay, determinant of A with respect to y and determinant of capital A. So definitely this determinants comes in denominator. That's why only we are saying that definitely D is not is equal to 0. Definitely if the determinant value is not is equal to 0, then you can find the x and y. Those x and y solutions are unique solutions. Those are the solutions of those. Then how you can find this dx value? Okay, so dx value you can find, for example, you have a1, b1, a2, b2. Whenever you are going to find the small x, okay, with respect to x, x coefficients are a1, a2. Replace x coefficients a1, a2 by constant matrix. Constant matrix is capital B, C1, C2, and the remaining y coefficients B1, B2 will be as it is. So now apply the det for them. If you apply the det, something you will get some value, it is not is equal to 0. Now for d suffix y, det of matrix A with respect to y means, so write down the x elements as it is a1, a2. We are changing y elements now. So replace y elements with constant matrix. Okay, a1, a2, c1, c2. Now take the det. It is also not is equal to 0. This determinant you will get one constant number. You will get one constant number, and capital D is also will get one constant number. By doing that process, you will get the solution of small x and solution of small y. This is the total brief explanation of the Cramer's rule. Now the same concept we are going to use in our Newton Raphson method in nonlinear method. So therefore, you can see here system of equations 4 is also in that format only. So now this equation 4 has unique solution if capital D, here D is nothing but determinant. D is nothing but determinant. Determinant of what? Determinant of coefficient matrix. Here this dou f by dou x naught, dou g by dou x naught, these all are the coefficients of variable h and k. In place of x we have h, in place of y we have k. Here h and k are the variables and partial derivatives are the values. So therefore this is the coefficient matrix capital A. For that capital A we are finding determinant. If the determinant not is equal to 0, then equation 4 has a unique solution. Then this capital D is then capital A is called non-singular matrix also. Whenever determinant value is not is equal to 0, then that matrix is called non-singular matrix. Okay, if det is equal to 0, det of any matrix is equal to 0, then it is called a singular matrix. So therefore, why determinant not is equal to 0 means we are taking the determinant in the denominator in the next approximation. So therefore, if the determinant is not is equal to 0 in the denominator, then only we can find the solution of small h and small k. So by Cramer's rule, the solution of equation number 3, the solution of this equation number 3 is given by, okay, so small h is equal to, previously I wrote now, so x is equal to dx by d, okay, d suffix x by d, and y is equal to d suffix y by d. Same only, small h is equal to this total mod value denotes that d with respect to h, okay, d, det of capital A coefficient matrix with respect to h. Here you can see first, here you can see coefficients of small h. Coefficients of small h means dou f by dou x naught, dou g by dou x naught were replaced by the constant matrix. What is the constant matrix here? RHS values of the equation number 4, that is f naught by g naught, f naught minus g naught, that is capital H by d. Next, capital K, by Cramer's rule only we are writing 1 by means 1 by d into this total matrix. The total matrix gives that d into d suffix k. That means the det of the coefficient matrix with respect to k. With respect to k means where k is nothing but you have to replace the k coefficients. Okay, dou g by dou x naught, dou g by dou y naught. So therefore those coefficients you have to replace with the constant matrix f naught g naught. Then k h coefficients will be same. Here h coefficients will be same. That is the method. Okay, so listen carefully once again. Here we are going to finding the solution of the given equation by using the Cramer's rule. Cramer's rule is nothing but whenever we are going to find out the system of a solution by using the matrices, so Cramer's rule plays key role. In Cramer's rule, first of all we have to find out the determinant of the coefficient matrix. If the determinant is not is equal to 0, then we can proceed forward. This determinant is not is equal to 0. Then by Cramer's rule you can write small h and small k. Why? Because here we have h is equal, x is equal to small h and y is equal to k. So therefore, now after taking those values, let initial approximation x naught comma y naught is equal to 0.5 or 0.5. Okay, why? Because actual root is 1 comma 1. Initial approximation is less than 1 only. So therefore 0.5 comma 0.5 be the initial approximation. Now after taking the initial approximation, substitute in, we have to find out the f naught value. We have to find out the f naught value, g naught value, dou f by dou y, dou g by dou naught value. We have to find out those values. So therefore, now find out all those values. Find out all those values. Then you will know that. So therefore, f naught is nothing but function in term, we have to replace with the x naught comma y naught. So therefore 3 x naught y naught square minus 10 x naught plus 7. So substitute those values. So you will get f naught is equal to 2.3750. F naught, if you substitute that x naught in place of x in equation number 1, okay, x naught is nothing but 0.5 and y naught is equal to 0.5, and if you simplify you will get f naught value. Similarly, g naught is equal to g of x naught comma y naught in equation number 1, y naught square minus 5y naught plus 4. So therefore g naught is equal to 1.75. Okay, all constants only. Next, partial derivative with respect to x naught. Dou f by dou x naught is equal to, substitute the value 6xy minus 10, 6x naught y naught minus 10 is equal to minus 8.5. Okay, so therefore dou f by dou y naught is equal to 0.75, dou g by dou x naught 0, and This one is the minus 4. We have got all the values. Now consider capital D, determinant of coefficient matrix. Okay, so therefore determinant of dou f by dou x naught, this value, substitute all the values and to take the dead term, you will get 34. Capital D is equal to 34. What is the D? Determinant of coefficient matrix is 34. Therefore 34 not is equal to 0. Then the given system of equation 3 has a unique solution. System of equation 3 has a unique solution. So therefore now the values, those solutions are h and k. We have to obtain them as h is equal to 1 by d. Actually h is equal to, you can write d with respect to h by capital D. This total modular value, debt value is there na, so that is equal to d with respect to h only. So therefore that means h coefficients we have to replace with constant matrix, where constant matrix is RHS values of the equation number 4. So therefore you can write this, so you can proceed this in this format. You will get, so 1 by d, 1 by 34, substitute all those values, minus f naught, minus g naught. So therefore those values substitute and take the determinant value, then you will get small h is equal to 0.3180. 0.3180 h is equal to, and k is equal to, also substitute the equation by Cramer's rule and substitute the all values, corresponding values, and simplify them. You will get k is equal to 0.4375. So where what are the h and k? H and k are the solutions of the given equation number 4. F of x naught plus h and y naught plus k is the solution, is the root of the given system of equation number 1 we took earlier. So therefore this x naught minus we know, and h and k are the these values. So now original solution x1 is equal to, x1 you can write, x1 is equal to x naught plus h, x naught plus h, and y1 is equal to y naught plus k, y naught plus k. How you can write those values? Okay, so therefore x1 minus x naught is equal to small h, and y1 minus y naught is equal to small k. So this gives the new approximations. So therefore the first approximation is x1 is equal to, substitute the x naught value and h value, you will get x1 is equal to 0.8180, and y1 value, substitute the y naught value and k value, you will get y1 is equal to 0.9375. So from these two values, first approximation. Next, with the help of x1 comma y1, now we are going to find out the f of f1. For the next approximation, to apply the Cramer's rule, then you will get f1 minus g1 minus dou f by dou x1, dou g by dou y1. These values you will get. So for them, now with respect to, with the help of x1 comma y1, find f1. f1 is equal to f of x1 comma y1. Substitute the value, corresponding values, and simplify, you will get f1 value, and g1 you will get g1 value, and dou f by dou x1 you will get that value, and dou f by dou y1 you will get that value, and dou g by dou x1 and dou g by dou y1 you will get all the values. After getting those all the values, apply the determinant value. Okay, so therefore capital D is equal to formula dou f by dou x naught. Earlier we have dou f by dou x naught. Now dou f by dou y1. So therefore in that format you have, so therefore substitute the corresponding values and simplify them, you will get that capital D determinant value is equal to 16.8713. It is also positive number not is equal to 0. Capital D not is equal to 0. Then we can proceed further. The values of h and k are obtained as h is equal to formula, okay, 1 by d into minus f1 minus g1. So substitute the values f1 g1 as we derived previously. So therefore substitute them and simplify them, you will get those values. So therefore what is the h value here? 0.1528, and k, what is the k value? 0.0612. That gives the total first approximation. Okay, now second approximation, x2 is equal to x1 plus h, x2 is equal to x1 plus h. So therefore substitute the x1 value and h value 0.1528 and x2 is equal to 0.9708. y2 is equal to y1 plus k. So substitute the y1 value and k value, you will get y2 is equal to 0.9987. Observe carefully. Here x2 value is the after initial approximation. Initial approximation we started with 0.5 comma 0.5. Next x1 we got, okay, x1 we got 0.8, y1 we got 0.9. Next to x2 we got 0.9, y2 we got 0.9. That means these all initial approximations gradually converging towards 1 comma 1. X is equal to y is equal to 1 comma 1. So next in the second approximation, same process. If you repeat f2 value and g2 value and dou f by dou x2 and dou g by dou x2 and dou g by dou y2, if you find all them and again consider the Cramer's rule, capital determinant d value and substitute those corresponding values of the functions, therefore you will get again capital D, determinant value is equal to not is equal to 0, 12.5593. After getting the determinant value not is equal to 0, you can find out the h and k values. This process you have to do until you get that h and k values is equal to 0. Okay, so this is the h value and you can get the next page k value. So this is the k value. This h and k gradually decreasing their values. If you observe in the first approximation, if you compare with the second approximation, h and k values gradually decreasing and x1 y1 values gradually increasing. Okay, so therefore third approximation x3 is equal to, here you can see clearly, so it is approximately equal to 1, x3 value. Y3, it is also exactly equal to 1. So f of x3, f3 value and g3 value. So these all are the corresponding values after finding them. So substitute in capital D, where again determinant is also not is equal to 0, 12.0126. It is also not is equal to 0. So then capital H is small h is equal to, again we are getting 0.007. Okay, if you compare with the previous approximation small h value, this h value is decreasing and here k is equal to 0. Previously we got k is equal to something 0.00. Previously we got k is equal to 0.0013. Now we got directly k is equal to 0. Now in fourth approximation, x4 is equal to x3 plus h. Therefore x4 is equal to 1 and y4 is equal to 1 and f of 4 y4. So find this all the corresponding values and substitute them. So here you will get again determinant is equal to 12. 12 is not is equal to 0. Then so the values of h and k obtained by same formula. Here h is equal to 0, k is equal to 0. So by applying that Cramer's rule, we can find that h and k values. So h is equal to 0 and k is equal to 0. So therefore now in fifth approximation, x suffix 5 is equal to x suffix 4 plus h. So x suffix 4 value is 1, 1 plus 0 is equal to 1, x suffix 5 is equal to 1 and y suffix 5 is equal to 1. So with the help of Newton Raphson method, we can find the exact root of the given equation, given system of nonlinear equation. Same system of nonlinear equation we find by using that method of iteration, where we derived that x is equal to 0.998 something and y is equal to also 0.9997. That means those are very close to 1 with the help of the iteration method. But with the help of Newton Raphson method, we got x is equal to 1 and y is equal to 1. These are the actual roots of the given system of nonlinear equations. Okay, so therefore the roots of the system of equation number 1, x comma y is equal to 1 comma 1, x5 comma y5 is equal to x comma y is equal to 1 comma 1. Okay, so this is the total explanation of the given Newton Raphson method in the system of nonlinear equations. So here by using the Cramer's rule only we are going to solve this equation. That is only. This is the total explanation of this theorem. Okay, so I hope you understood this theorem very well. In the next lecture we are coming with sorry This is the total explanation of this problem. Okay, I hope you understood this problem very well. In the next lecture, we are coming with another interesting topics. Okay, prepare well, make a perfect practice. Until bye, thank you.